Hey guys, today we're going to look at 9-3, reducing radicals. So today we're rewriting radical expressions. So the first question it wants us to look at is how do we compare the square root of 20 and 2 times the square root of 5? Well, we have something called the product property of square roots. Okay, the product property of square roots says that if you have a product underneath a radical, you can break it up into the square root of the first number times the square root of the second number. Okay? So we're going to use these properties of square roots to show an equivalent expression for the square root of 20. So when you rewrite radicals, you always want to look for something that is a perfect square. Okay, a perfect square means you can take the square root of it. So I'm thinking through the factors of 20. Okay, so I've got obviously 1 times 20, 2 times 10, and 4 times 5. Okay, what can I take the square root of? Well, I can take the square root of 1, but we never think about 1 because it really doesn't help us. Can I do the square root of 2? No. What about the square root of 10? No. Square root of 4? Oh, I can do the square root of 4. So 20 really breaks down to 4 times 5. So I can rewrite the square root of 20 as the square root of 4 times the square root of 5. Well, looking at this, I know the square root of 4. The square root of 4 is just 2. So I pulled that out. Do I know the square root of 5? No. So I leave 5 underneath the radical. So the square root of 20 simplifies to 2 times the square root of 5. Okay, so let's take a look at a couple more examples. Pause the video and see if these two are the same. Okay, letter A, we have the square root of 36 and 3 times the square root of 6. Well, the square root of 36, you all should know that. That's just 6. 6 and then 3 square roots of 6. Can't go any further. So these are not the same. Okay, pause the video, try letter B. Okay, so I'm not going to touch 6 square roots too. So let's look at 72. Okay, 1 times 72. 2 times 36. 3 times, let me think a second, 24. 5, 6 times 12, and 8 times 9. Okay, we're looking for something that we can take the square root of. Well, I know I can do the square root of 36, and I know I can do the square root of 9. Which one's bigger? This one is. Okay, so we're going to use the biggest square root. So the square root of 72 really breaks down to the square root of 2 times the square root of 36. Okay, well, I don't know the square root of 2, so he stays. Square root of 36, that's just 6. So I'm going to pull that out front. So, oh, look at that. They are the same. Okay, those are equivalent. So we're going to break down another one here. Okay, square root of 63. Again, I'm going to list my factors. I have 1 times 63, 3 times 21, 5, 6, 7 times 9. Okay, that's all my factors. Which one can I take the square root of? Well, I can't do the square root of 3, can't do the square root of 21. So not that one. Okay, square root of 7, no. Oh, square root of 9, I know that one. So I'm breaking this down to the square root of 7 times the square root of 9. I don't know the square root of 7, so he's going to stay under the radical. Square root of 9, oh, that's just 3. So this breaks down to 3 times the square root of 7. Okay, so you really need to know your perfect squares. So you should be able to tell me that 1 squared is 1, 2 squared is 4. Nine squared. Okay, you should know these. Okay, you need to know them frontwards and backwards. Okay, what I mean by frontwards and backwards, 9 squared is 81. You should also be able to tell me the square root of 81 is equal to 9. Okay, you need to know these ones frontwards and backwards. Okay, you might have a pop quiz on these sometime soon. Okay, so make sure you know those. These are going to help you when you're reducing radicals. Okay, so we're going to rewrite these expressions again as what we call a hidden perfect square. Okay, so go ahead, pause the video and try letter A. Okay, letter A, again, I think it's helpful to list the factors if you can't recognize that perfect square inside. So I know it's 1 times 44, 2 times 22, 3, no, 4 times 11, 5, 6, okay, that's all. Okay, obviously I can only take the square root of 4. So this breaks down the square root of 4 times the square root of 11. Square root of 4 is just 2, and then the square root of 11, 6. Okay, pause the video, try letter B. Okay, I'm looking at this. I got square root of 27, so 1 times 27, 3 times 9, that's all of them. Okay, so obviously it's going to be this one. So the 3 outside I leave alone. Okay, it's just like a coefficient for right now. And then I have the square root of 3 times the square root of 9. Again, I'm leaving this 3 alone. Oh, square root of 9. That's just 3. And I don't know the square root of 3, so I leave him alone. Now, we're just going to multiply these together. Okay, 3 times 3, 9 times the square root of 3. Okay, so that's how we do the numbers. Let's throw some letters in there as well. Okay, so we're going to look at the square root of 63, x to the 9th. So sometimes it's easier to separate it and really just concentrate on the numbers, and then we'll concentrate on the letters afterwards. Okay, so the square root of 63 we actually just did. This was the square root of 7 times the square root of 9. Okay, square root of 7 we don't know, so he stays. Square root of 9 is 3, so 3 square roots of 7. Okay, now here is a little bit different. When we're talking about square roots, what is the little understood number inside the check mark? Well, this is a 2 for square root. So we're going to do some long division. I'm going to take my exponent, and I'm going to divide it by the root. How many times does 2 go into 9? Oh, it goes in 4 times. Okay? And we have 1 left over. Okay? So what we end up doing, this is how many x's we pull outside. So I have x to the 4th, and the remainder is how many stay inside the radical. Okay, x to the 1st stays inside. Okay, this comes out, this stays inside. Okay, so now we're going to put these two things together. Okay, so my coefficients outside gives me 3x to the 4th, and then I just multiply the two things underneath. Okay, 7x. That's how you do it with letters involved. Okay, your turn to try. Pause the video, try letter A, please. Okay, letter A, I see square root of 25, x cubed. Okay, again, you can focus on one at a time. So if you like, break it down. Square root of 25, square root of x cubed. Well, square root of 25, that's just 5. And remember, we do our long division here. 2 goes into 3 once, and I have 1 left over. So 5x times the square root of x. Pause the video, try letter B. Okay, letter B, again, you can break it down if you want. So I have 5, square root of 4, square root of x to the 17th. Okay, obviously, the 5 stays the same. Square root of 4, well, that's just 2. Okay, now I'm going to play with the x's. Remember, here's a 2. So how many times does 2 go into 17? 8 times. So I pull out an x to the 8th, and we had 1 left over. One more step. Let's combine everything. 5 times 2 gives me 10, x to the 8th, square root of x. Okay, so now that we've broken them down, let's see what happens when we multiply two of these together. Okay, so it's not too bad. We start by multiplying our coefficients. So I have 3 times 2 is 6. And we multiply the stuff underneath the square roots. So 5 times 15, that gives me 75. X times x cubed gives me x to the 4th. From here, now we can break it down just like the last problem. Okay, the 6 stays the same. I'm going to concentrate on the square root of 75, and I'm going to concentrate on the square root of x to the 4th. Okay, 75. If you think them through, it's 25 times 3. Okay, so square root of 3, square root of 25. Okay, so obviously we're going to keep the 6. Square root of 25, oh, that's just 5. And I'm going to leave the square root of 3 alone. Okay, x to the 4th. Again, we think of this as a little 2. How many times does 2 go into 4? Well, it goes in twice. Are there any leftovers? Nope. So we are done there. So now I'm just going to put it all together. multiply your coefficients. So 6 times 5 is 30, x squared, and anything left underneath the radical, square root of 3. Your turn. Try letter A, please. Again, you start with the coefficients. Half times 4 is 2. We're going to multiply everything underneath. 21 times 7 is 147, x to the 5th. Okay, so now would be a really good time to be writing out the factors of 147. I don't personally know these off the top of my head, so let's see what we got. Okay, so I know it's 1 times 147. Okay, 2 doesn't go in. 3 times 49. Oh, that's a square right there. Since it's the bigger of the two, like I already know it's going to be my biggest number, I'm going to use this. Okay, so I'm going to do 2, square root of 3, square root of 49, square root of x to the 5th. Okay, well, obviously the square root of 49 is 7. And then, okay, I think about this. 2 goes into 5 twice, so I plot an x squared. There's a remainder of 1. So now we're going to multiply all of our coefficients together. 2 times 7 is 14, x squared. And the stuff underneath the radical gets multiplied together too. Square root of 3x. Okay, pause the video and try letter B. So letter B, I'm going to take my coefficient, and I'm going to do everything underneath. 12 times 18 gives me 216, and then I multiply, so x to the 14th. Okay, again, I don't know my factors at 216, so I'm going to write them out. 4 times 216, 2 times 108, 3 times 72, 4 times 54, 5 doesn't go in, 6 times 36, 7, no, 8, yep, 8 times 27, 9, 10, 11, 12. Okay, so this is enough here. Okay, I always start by looking here. Can't do square root, nope, nope. Oh, this is the biggest one I have. So this turns into 2 times the square root of 6 times the square root of 36 times the square root of x to the 14th. Okay, go ahead and go through them. 2, square root of 6, square root of 36 is just plain old 6. And remember, 2 goes into 14 7 times. So I pull out an x to the 7th. Multiply everything without a radical, so 12 x to the 7th times the square root of 6. Okay, and last thing we're going to look at is a word problem. So a light fixture in an ice cream shop is in the shape of an ice cream cone, and the cone has a height that is 7 times the radius. Okay, 7 times the radius. Where r is, and then we have the expression for the slant height is r squared of r squared plus h squared, where r is the radius and h is the height. The slant height should be no longer than 24 inches to fit on the wall. What is the slant height of the cone with the radius shown? Well, I know we have square root of r squared plus h squared. It tells us our radius is 3. We also know that the height is 7 times the radius. So 7 times my radius would give me a height of 21. So I'm going to do the square root of 21 squared plus 3 squared. 21 squared is 441. 3 squared is 9. Okay, this gives me the square root of 450. Okay, we need to know it has to be no longer than 24. So I'm just going to take the square root of 240 or 450. This is approximately 21.21. Will the ice cream cone fit? Yes, it will, because we are shorter than 24 inches. Okay, number 5 is a little bit different. Another cone has a slant height s that is 5 times the radius. What is the simplified expression for the height in terms of the radius? Well, remember, it just told us that it was r squared plus h squared. Okay? So our slant height simplified expression in terms of the radius. So I know slant height s is 5 times the radius. Okay, so s, I'm going to write 5r equals square root of r squared plus h squared. Okay, so what this is saying is get h by itself. Okay, we want to get h by itself. So the first thing we need to do is get rid of the square root. So I'm going to square both sides. So 5r squared means 5r times 5r, 25r squared, equals r squared plus h squared. And again, I'm solving for h. So the next thing I want to do is subtract the r squared, giving me 24r squared. Okay, how do I get h alone? Well, now I got to do the square root. So I'm going to go ahead and switch sides. H equals. Okay, let's break down the square root of 24r squared. Okay, 24 we know is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Obviously, this is our perfect square. So h equals the square root of 4 times the square root of 6 times the square root of r squared. Well, this is 2, square root of 6. Those cancel, just r. So my final answer is equal to 2r square root of 6. And that's how you simplify these radicals. Okay? So here's your homework for tonight. Please make sure you come with questions. See you guys later.